Welcome to the next topic of discussion, which is linear measurements. In this lecture, we will have a small introduction, followed by it we will try to have a design of linear measurement instruments, surface plates, V blocks, graduated scales, scaled instruments, vernier instruments, micrometer instruments, and finally slip gauges. These are all used for measuring linear measurements. So, measuring instruments are designed either for line measurement or for end measurement. We saw earlier how do we convert line to end and end to line, we saw all those things. So, when we talk about line measurement, the examples are nothing but steel ruler or vernier caliper. In order to make sure the distance between the two surfaces using an instrument is flat. So, this end measurement is always to make sure that the flat surfaces are in contact, and then we try to measure the length. Example is screw gauge. Vernier caliper and micrometer are the most widely used linear measuring instruments in machine shop and in tool room as well as in academics. Calipers and dividers, which are also linear measurement devices. Caliper is something like your gauges, plug gauges. So, you try to have a caliper, you try to set a diameter, or you try to measure a component, set the diameter, pull it out and then keep it in front of a line measurement and try to take the dimensions. Same with divider also, which are also linear measurement devices, are basically dimension transfer instruments. They will not directly provide the measurement of length on a scale. So, they will not directly provide, but what we do is we try to take it something like a comparator. Put a pen, try to measure the dimensions, and then when you measure it, it is just like a gauge. So, you just push it inside, note down the diameter, pull it out, take it to a scale, measure it. The linear measurement tools are used in our day-to-day life are many. So, for example, we use a scale for measurement, for drawing line, and if you talk to a mason, he always measures with respect to a measuring tape. So, all these things are linear measurement. So, the design for linear measurement instrument is, the linear measurement instrument have to be designed to meet stringent demands for accuracy and precision. Now, you will be able to distinguish what is accurate and precision, right. At the same time, the instrument should be as simple as possible to operate and allow price and low price to make it economical sense for the user. So, here the instrument must be as simple as possible. See, when you try to have any instrument you have, so what are the major things it has to be? First thing, it has to show clearly the values whatever you obtain or measure. Next, it has to be simple for using. So, that means to say it should not demand a skilled laborer to use this instrument. The third thing is, it should be accurate and precise in its measurement. It should have good repeatability in its data. It should have wear resistance. From usage. Usage is any environment. Okay. It should be economical, so that people can buy it. So, these are some of the characteristics should be there for any instrument. Okay. It should be clear, it should show or display clearly the measured values. it should be simple to use, it should be accurate, and it should be precise. So, when you put that, repeatability gets into these two definitions. So, it should have good repeatability. So, that means to say the mechanism whatever you use should not try to bring in any change erratically. It should have wear resistance, good wear resistance. It should have good wear resistance to usage. It should be as economical as possible. So, these are some of the characteristics or features which you expect from any instrument, linear, let it be angular, but in particular instrument. Following are the considerations for design of linear measurement instrument. The measuring accuracy of line graduated instrument depends on the original accuracy of the line graduation. Excessive thickness. So, excessive thickness or poor definition of graduating lines affects the accuracy of readings captured from the instruments. Whatever I said earlier, clarity. Any instrument incorporating a scale is a suspect unless it provides compensation against wear. So, I told you it has to have good wear resistance, the original accuracy of the line graduation. The attachment can enhance the versatility. That means to say you try to have add-on modules to it, so that you can try to do many more different measurements. So, the attachment can enhance the versatility of the instrument. However, every attachment used along with an instrument, unless properly deployed, may contribute to accumulated error. That means to say, if you are trying to fix one more attachment to your scale, and if the attachment is not fixed properly, then there is going to be an error. So, this error is going to give you a value which is not original. Use attachments when their presence improves reliability more than their added chance of error decreases it. Then instruments such as caliper depends on the feel of the user for their precision. So, when you put a shaft and then you put a caliper, the looseness of the caliper or the tightness of the caliper is based on the feel of the person who uses. So, the instrument such as caliper depends on the feel of the user for their precision. Good quality of instruments promote reliability, but it is ultimately the skill of the user that ensures accuracy. Therefore, it is needless to say that proper training should be imparted to the user to ensure accurate measurements when using these feeler calipers for linear measurement. The principle of alignment, which is very important. There is something called as Abaye's error. Principle of alignment is very important. The principle of alignment states that the line of measurement and the line of dimension being measured should be coincident. This is a very valid point. If the lines don't coincide, then there is a small angle which gives you a different value. For example, if they are not coincident and if it is inclined at an angle, so there will be a cos theta or a sin theta value added to the base when you get the result. The principle is fundamental to good design and ensure accurate and reliability of measurement. The cost is not an issue. Digital display may be preferred, because when you talk about second decimal and third decimal using mechanical and then screw gauge, it is always now becoming difficult. So, it is better to have a digital display, and the digital display displays to the second and then third decimal to get good results. And of course, today the stability of the electronics have improved a lot. So, and the battery life, the portability of these electronics have also become very large. Whenever a contact between the instrument and the surface of the job being measured is inevitable, the contact force should be optimum to avoid distortion. So, this is what is the example I asked you to work after my first lecture. I give you a skin, try to measure the surface roughness or measure the surface properties of the skin. So, a skin is an elastic material. So, depending upon the contact forces, the force what you apply on the skin, there will be deflection and change in the values. Dial version of the instruments add convenience to reading. So, dial version means, so we are talking about analog. Electronic version versus digital readout, provides digital readout that are even easier to read. However, neither of these guarantees accuracy and reliability of measurement unless basic principle are adhered to it. What is the basic principle? The coincidence between the two axes. So, this is very important. So, here if you want to go for electronic, it is digital, otherwise it is analogous output. So, this is an instrument which is called surface plate. Surface plate are generally made out of hard, solid, horizontal flat plate which is used as a reference plane for precision instrument. See what happens when you start doing all these measurements, at least one datum should be flat or one datum should be reference. For example, I put a surface plate, I put a L square to read, right, and here this is a flat surface. If there is any angle, then the L square will have at an angle theta, right, and this theta will try to give me a value which is L length into sin theta. So, you will get a different value. So, in order to make sure the measurement is correct, we always try to butt the instrument as against a reference plane. So, this is a reference plane and surface plate is a reference plane which is used for many instruments. For example, a height gauge is placed on a surface plate. Okay. The accuracy of a surface plate is very high and it is used as a datum for all measurements on your job. For example, if you want to put a shaft, if you want to put a flat plate, if you want to put any other objects, and if you have a reference surface, that reference plane should butt against the surface plate. Surface plate are done out of cast iron generally, and the surface of the surface plate will be always hardened so that it has very good wear resistance. The surface plate are made either of cast iron or of granite. So, why cast iron and granite? Because the coefficient of thermal expansion is very less, okay, and we do something called as a scraping operation. So, here we try to make pits and then we try to make it flat, okay. It will not be milled. Even though granite surface plates are perceived to be superior, cast iron surface plates are still used widely, because these granite, what happens, it is, though the thermal expansion and all is very good, but here it is brittle in nature. So, if at all there is a shock or something happens, then it will start cracking and it will break. The cast iron surface plate is used as a tool for lapping granite surface plates to the required degree of accuracy. Cast iron allows itself to be impregnated with a lapping media over a large surface plates. So, we always use this surface plates as a reference plane for measurements. So, when we talk about cast iron surface plates, they are made of either plain or alloyed close grained cast iron reinforced with ribs to provide strength. So, where are the ribs? So, if you look at it on the bottom side of this is a very heavy plate. So, on the bottom side of it, you see this is cast iron, you see here, on the bottom side you will see ribs. On the bottom side you will see ribs. So, these ribs add strength, provide against bending and buckling, because this is a very small surface plate. You can have surface plate of meter by meter. So, when you have a meter by meter large, so then there is a possibility of bending and deflection. Okay. IS 2285/1991 specifies the composition, size and the cross sectional details of the rib and the thickness of the plate. there are 3 grades which are manufactured for surface plate: 0, 1 and double. 0 and 1 are hand scraped to achieve the required degree of flatness. Grade 2 plates are precision machined to the required degree of accuracy. Scraping is an operation wherein which we try to make this surface flat. So, scraping, what we do is we try to make dents and remove material, and then we apply Persian blue, try to figure out the uniformity of the pits, and with that we try to come out with the flatness of the surface. So, these two are done by scraping. The accuracy is very high when you go to grade 2. So, these are the dimensions which are available, these are the grades. So, you can see maximum deviation flatness in microns: 4 microns, 15 microns. Okay. So, approximate weight, you see it is very heavy, it is very heavy. So, this is as per the standard. So, granite surface plate I have started replacing cast iron surface plates. Most surface plates are made out of black, while pink granite is the next preferred choice. So, black is very common. So, that is why you see surface plates, when you buy a CMM machine, coordinate measuring machine, the base of this coordinate measuring machine is always a granite. Okay. Granite has many advantages of cast iron. Natural granite that is seasoned in the open for thousands of years is free from warpage or deterioration. So, this is much better, warpage is less. Twice as hard as cast iron and not affected by temperature. So, granite has its own advantage as compared to cast iron, and cast iron is sometimes vulnerable to rusting. So, here it is no rusting and no magnetic field influence, and here it is free from burr or protrusion because very fine grain structures are there. So, this is very much used, this is very much popular, and today people have started using granite as compared to that of cast iron. So, according to this standard, you can see the grades 0, 0, 0, 1, and these are all in microns, okay, millimeters. So, you can convert into microns, and these are all the weights which is there. So, for just this thing example, so this is 1500 into 1200, which is around about 1000 kilos, which is here 900 kilos. So, it is slightly less, okay, approximately it is less. Okay. Next is V block. Let me first show the V block. This is a V block. So, here in this V block, we always try to put a cylindrical piece. A cylindrical piece is put, and then if you want to measure the height of it, you can start measuring it. If it is a magnetic material, so all you have to do is you put a flat plate and then you try to rotate the knob and magnetize it such that this V block gets firmly fastened to the surface plate, whatever you have. It is because of the magnet present. Okay. So, V block are extensively used in inspection of jobs which are having circular cross sections. V block, so circular cross sections, you can try to find out the height, you can try to find out other things also, right. So, inspection of jobs. Major purpose of V block is to hold a cylindrical workpiece to enable measurement. Otherwise, it is very difficult for you to hold. A cylindrical surface rests firmly on the sides of a V, and the axis of the job will be parallel to both the base and to the sides of the V block. Generally, the V is 90 degrees. You also get 120 degrees in some cases. Here, it is made out of steel, which has a hardness of 60 Rc, and then it is ground. It varies from size 50 to 200 millimeter. The accuracy of flatness, squareness, parallelism is all very low, 5 microns. The V block up to 150 millimeter, and it is 0.1 for anything more than that. So, there are two grades, grade A and grade B. So, based upon their accuracy, grade A V block has a flatness up to 5, for 150 millimeter as compared to that of B. So, A block grade is much better than B grade. So, I have already explained to you. Next is scaled instruments. So, till now what we saw was, we saw linear. Now, we are going to see scaled. First is depth gauge. Let me first show you a depth gauge. So, this is a depth gauge. So, you have several graduations. You have a pin or a plunger. So, this goes inside the hole. You try to go fit inside the hole, and correspondingly this is adjusted height, and then you can see the graduation, what is the depth which it has to undergo inside a hole and measure it. So, this is a depth gauge measurement. So, the depth gauge is preferred instrument for measuring hole, grooves and recesses. Suppose if you have a blind hole, if you want to measure the height of it, depth gauge is the only possibility which can be used to measure. Okay. So, you can also have holes, hole is through to through, you can have grooves, you can also have recess. So, we use the depth gauge. It basically consists of graduated rod or rules that can slide in a T-headed or a stock. The rod or rule can be locked into a position by operating a screw clamp, which facilitates accurate reading of the scale. The head is used to span the shoulder of the recess, therefore providing a reference point for the measurement. The rod or the rule is pushed into the recess until it hits the bottom. The screw clamp helps in locking the rod, and the depth gauge is then withdrawn, and you see, read the readings accordingly. The depth gauge is useful for measuring inaccessible points in a simple, in a convenient manner. So, this is the depth gauge. So, you can see here graduations, and the least count can be up to 1 micron. Generally, it is 10 microns. It can go up to 1 microns. This is the least count. What is least count? Least count is the minimum distance between two graduations. Next one is an interesting thing, which is a combined set. A combined set has 3 devices built into it. So, till now what we saw was only a single instrument, a V block, right? A V block, a flat plate, a depth gauge, maybe a vernier, a screw gauge. So, all these things are individual equipments. Suppose if we wanted to find out several features, the dimensions of several features with respect to one flat plate or one reference plane, then we would like to go for combined set. Combined set or combination set. A combination set has 3 devices built into it. A combination of a square comprising a square head and a steel ruler, a protractor head and a center head. It has 3. What are they? A square head, a steel ruler, a square head and a steel ruler, a protractor head and a center head. The combination square can be used as a depth or a height gauge. The protractor head can be used as a angle gauge or angle to measure the angle of the job. The center head combines in handy for measuring diameter of the job, having a circular cross section. So, is it clear? So, here is one square, protractor and then center head. Okay. The combination square can be used as a depth or a height gauge. The protractor head can be used for measuring angle. The center head comes in handy for measuring diameter of the job, having a circular cross section. A combination set is very useful extension of a steel ruler. Steel ruler was basically to measure the length. This non-precision instrument is rarely used in any kind of production inspection. It is frequently used in tool rooms for tools and die making. It is versatile and interesting instrument that has evolved from tri-square. What is tri-square? Tri-square is something like this. Okay. tri-square. It is tri-square, which is used for checking the squareness between two flat surfaces. This is tri-square or a T-square. Okay. People call it as tri-square and T-square. So, this is what it is. So, here is a V block combination set. Here is a V block. Here is an angle which you would want to measure, and you also can measure the depth of it by aligning it. This is a very wonderful equipment, and really you need skill to use this. So, the advantage is, if you have, I would like to redraw, if you remember, I would like to redraw the same component which we discussed last time. Angle is 60 plus or minus 2 degrees. From here it is 40 millimeter plus or minus 0.1. It is maybe 40 plus or minus 0.1. So, in this, if you see, there is an angle, there is a height to be measured, there is a depth also, there is a depth. Okay. So, this is up to here. I am sorry, this is up to here. So, you have a depth, you have an angle, you have a length to measure. So, then this in one shot can be measured using this combinational set. So, this slides on the scale. This also you can set a V block, so that cylindrical component. This is for at an angle. So, when you put in combination of this you try to get the result out of it. The next one is a caliper. A caliper is basically to take the dimensions, but it will not give you the values. It is only to take the dimension, take the shape and then transfer it. So, there are many jobs whose dimensions cannot be accurately measured with steel ruler alone. So, there we always try to, typically for a circular cross section jobs, we cannot use a steel ruler. So, then we go for a caliper. The attempt of making measurement using a steel ruler alone will lead to an error, since the steel ruler cannot be positioned diametrically across the job to the required degree of accuracy. One option is to use a combination set. However, calipers are the original transfer instruments to transfer such measurements onto a ruler. They can easily capture the diameter of the job, which can be manually identified as a maximum distance between the legs of the caliper that can just slide over the diameter of the job. Calipers are like snap gauges, right. So, even though calipers are rarely used in the production inspection, they are very widely used in the tool room. So, combination set is also, operation is very difficult. Combinational set, then we talk about caliper. These are all used in tool rooms. Tool rooms, basically tool rooms are rooms wherein which is used for grinding or manufacturing a tool which can be used in the regular process line, or they try to make tools. For example, die is a tool for metal, for injection molding. So, they make tools and then they give to the regular production time, or they try to take a HSS tool or maybe try to take a HSS drill, or they try to manufacture a lapping tool. So, all these things are done in a tool room. So, here they use this caliper very much. So, caliper can be of two things, one is firm joint and another one is spring based. You can see even compasses or dividers are firm joints and spring joints. Again, in firm it can be outside caliper, it can be inside caliper. This is for OD, this is for ID. Okay. This is OD and ID. So, same way with spring also you can have for OD and ID, and you also have firm joint caliper and transfer caliper. These things are just to transfer the values, where even which you will also have a scale to take care of this measurement. So, these are the different types. So, this is inward, this is outward, and this is also, you can try to put an attachment and make it inward, or you can make it outward dimensions. The next instrument for discussion is vernier caliper. This instrument until now can be called as non-precision instrument due to their lack of precision, but for their lack of amplification. A steel ruler can measure accurate up to 1 millimeter. At the best, it can go up to 0.5 millimeter. If you want to go less than that, then we have to use instruments like vernier caliper and screw gauges. It is not sensitive to variation in dimensions at much finer levels because of the inherent limitation in the design. On the other hand, vernier instruments based on vernier scale principle can measure up to a much finer degree of accuracy. In the other words, they can amplify finer variation in dimensions and can be branded as precision instruments. So, and discussed until now what did we discuss? We discussed about caliper, right? We discussed about caliper, we discussed about linear measuring ruler, we were listening about combination. Okay. All these things were not highly precision, but moment when you come to this vernier, we are having very high precision. So, let us calculate the vernier caliper's least count. So, the minimum length or the thickness that can be measured with a vernier is called as the least count. Least count. What is the least count for a TFT monitor? It is 1 pixel. Okay. When you talk about rapid prototyping, what is it? It is called as voxel. Okay. When you talk about a scale, ordinary scale which you use for measuring, the between two graduations, that is least count. The least count of a vernier instrument can be found out by performing the following step. So, what we do is n VSD equal to n minus 1 MSD, vernier scale division and main scale division. So, 1 VSD equal to n minus 1 by n MSD, main scale division. So, least count is nothing but 1 MSD minus 1 VSD, vernier scale division. So, the least count is 1 MSD minus n minus 1 by n MSD, correct, and then this the least count can be written as 1 minus n minus 1 by n MSD. So, then least count is nothing but 1 MSD by n. So, the total reading, whatever we do, it is MSD plus vernier scale least this thing. So, here let me explain the acronym. MSD is the main scale reading, MSD or MSR, a main scale division. Okay. LC is the least count and VC is the vernier scale. Okay. If you want to call it as VCD, if you want to call it as, have I call it as VSD? VSD, it is vernier scale division. Okay. So, this is how we try to calculate the LC for a given vernier. Okay. This is 1 MSD by n, n is number of divisions. So, in a vernier caliper consists of two parts. One is main scale engraved on a solid L shaped frame. Then you have a vernier scale that is sliding on a main scale. So, this is the main scale, then assume that there is a block which slides on it, right. So, this is what is vernier scale. The sliding nature of the vernier has given it another name called as sliding caliper. The main scale is graduated in millimeter up to a least count of 1 millimeter. The vernier has engraved graduations which are either a forward vernier or a backward vernier. The vernier caliper is made out of stainless steel or tool steel depending upon the sensitivity. So, this is the main scale reading and this is the vernier scale division. Okay. If you put a component here, so first what we do is this can be used for external and this can be used for internal. For example, I can put a component something like this. So, you can use it for this is for external, this is for external and this is for internal features. First we just slide this across the main scale division and then what we get is we try to see what is the value for 0. So, that we try to know what is a millimeter and then what we do is we try to match this graduation whatever is here with respect to the graduation which is there on the main scale division. Moment one of these graduations meet, so then what we do is we take this, then we add this and then we try to take the vernier scale division. You also have vernier depth gauge. Vernier depth gauge is a more versatile instrument which can be used for measuring up to this and even smaller. The lower surface of the base has a blunt firmly against the upper scale of the hole and recess. So, we have already discussed. So, it has a nut to slide and then loosen it. The main scale is lowered and then one should avoid excessive force to be applied so that it does not deflect. So, this is a depth gauge. So, here it rests against the maybe a component or whatever it is. So, this is a component, this is the depth and again this is the main scale division and this is the vernier scale division. First slide, get the 0 value and then we see a matching value, multiply it with some factor which is given here. So, with this 0.05 division we multiply and then we try to get whatever is the answer. Vernier height gauge we have already seen. So, I do not want to cover in depth much, it is the same. So, here if you see here there is a screw which when you put it, when this part hits against the reference plane, then you tighten it and then remove the scale out and see what is the readings. Okay, vernier height gauge it is the same. So, I need not go in depth on this. So, this is the a vernier depth gauge, this is vernier depth gauge and in the very similar fashion you will also have vernier height gauge. Okay, vernier height gauge. So, here is a vernier height gauge. This vernier height gauge by the way can be put on a surface plate. This is a surface plate where the reference on the surface and the flat on the base are butted with each other, so that you do not get any angle theta value for this plane. So, here is a height gauge, again the same concept of depth gauge. You have a vernier here, you have a main scale division here and here you can try to put your end surfaces or you can try to make a small attachment and even put a cylindrical one and start measuring it. For example, if you have a flat plate and if you want to measure and draw lines for some applications, then what we do is we try to machine this workpiece and make the surface flat and then keep it on a surface plate and then use the height gauge and then we try to scribe the line on top of the surface so that we try to get the marking. So, with this now either you can punch or you can do any operation of your choice for further machining. So, let us take a simple example here to solve the problem. So, a jaw of a vernier caliper touches the inner wall of a calorimeter without any undue pressure. And by the way, when you use all these instruments, make sure that you do not apply tremendous pressure. That is why in screw gauge, if you see, after the shaft is put inside, we start rotating the screw and then later when we start rotating the vernier screw head, we just wait for the click sound, because the click sound will try to apply uniform pressure on the cylindrical component. The position of the 0 of the vernier scale on the main scale reading is 3.48. the sixth of the vernier scale division is coinciding with any main scale division. Vernier constant of the caliper is 0.01 centimeter. Find actually internal diameter of the colorimeter when it is observed that the vernier scale has a zero error of minus 0.03 centimeter. That means to say there is a instrumental error. Over a period of time wear and tear has happened. So, they figure out there is a error of minus 0.3. So, now let us try to solve the problem. So, what is the main scale reading is equal to 3.48 centimeters. I will also take it here centimeters, right. Then the least count is nothing but 0.01 centimeter. So, vernier coinciding which is nothing but 6. Now, the reading whatever is showing, reading is nothing but MSD reading, main scale D reading, or if you want to say main scale, you can call it as main scale reading. I will change it into MSR, okay, main scale reading plus vernier scale, vernier coinciding into LC. So, this is nothing but 3.48 plus 6 into 0.01. So, which is nothing but 3.54 centimeter. So, the corrected reading, which because we said there is an error. So, corrected reading is equal to reading minus the zero error, which is nothing but 3.54 minus 0.03, which is nothing but 3.54 plus 0.03, which is 3.57 centimeters. So, the corrected reading will be this. So, for this problem it is a very trivial problem, main scale reading plus vernier coincidence into LC. So, we got this. So, now what we say is this is the minus value. So, reading minus 0 error. So, this minus gets compensated. So, it becomes plus, and then the final answer is 3.57. Let us take one more problem to solve. The main scale of a vernier caliper is calibrated in millimeter, and 19 divisions of the main scale are equal to 20 divisions of the vernier scale. In measuring the diameter of the cylinder by this instrument, the main scale division reads 35 divisions, and the fourth division of the vernier scale coincides with main scale division. Find LC and find the radius of the cylinder. So, first let us take the least count to be figured it out, least count. So, it is nothing but main scale division is nothing but 0.1 centimeter, and if you want to have 20 vernier scale division is equal to 19 MSD. So, VSD is nothing but 19 by 20 MSD, which is nothing but 0.095 centimeter. Okay. This is the least count, is it right? No, this is the VSD. Least count will be, least count is nothing but MSD minus VSD, which is nothing but 0.1 minus 0.095, which is nothing but 0.005 centimeter. This is the least count. So, now let us try to find out the radius of the cylinder. Now, radius of the cylinder. So, here main scale reading is equal to 35 millimeter, which is nothing but 3.5 centimeter, because I am trying to make it to a uniform standard. So, the diameter is equal to main scale reading plus vernier coincidence into least count. So, this is nothing but 3.5 plus vernier is 4 and the least count is 0.005. So, this is nothing but 3.5 plus 0.02. So, this is 3.52 centimeter. So, we are asking the radius, and what you get here is diameter. So, 3.52 by 2, which is nothing but 1.76 centimeter. Okay. This is also a very simple problem. So, now you see we have given some real time examples. So, you measure this, what is the division you get, from that you are trying to find out the least count, and you are also trying to find out the radius of the cylinder. So, next we will move to outside micrometer. The outside micrometer consists of a C frame with stationary. So, this is the outside micrometer, or people call it as screw gauge. Okay. So, here it is 0 to 25, this is the least count they have given. So, here, okay. So, this is the main scale and this is the vernier scale, or here is that screw. So, what we do is we try to keep the component here, and then we start rotating, and then once it is very close and it is very tight, then we start rotating this knob until we get a click sound. Moment we get a click sound, the idea is uniform pressure is applied, so that we stop and look at the readings of main scale and the vernier scale to solve it. So, it consists of a C frame with stationary anvil and a moving spindle. So, this is a stationary anvil and this is a moving spindle. The spindle movement is controlled by a precisionally ground screw. The spindle moves as it rotates in a stationary spindle nut. The graduated scale is engaged on the stationary sleeve and a rotating thimble. The 0th mark of the thimble will coincide with the 0th division of the sleeve when the anvil and the spindle faces are brought together. So, before you start measuring, you are supposed to bring this to close to each other. Try to see whether this 0 and this 0. So, whether this 0 matches, so that you try to get the 0 0. If not, you try to note down the error and do the correction. So, vernier micrometer. So, this is outside micrometer. So, next is vernier micrometer. So, this is the vernier micrometer. You see here vernier scale and you see the dimple. The dimple is a nut which is attached, right, and here is a sleeve scale which is there. So, this is the master main scale. So, the micrometer that we use can provide an accurate to the best of 0.0 or 10 microns. Placing a vernier scale on the micrometer prints us to take a reading to the next decimal place. So, here it goes to the next, vernier takes us to the next decimal place. So, you can accurately measure up to 1 micron using this vernier micrometer. So, this is what is the dimple scale, and here are the graduations, and here is the sleeve. Digital micrometer is the latest which is there in order to get out of the ambiguity or measuring angle, if the principles are not followed. So, you might get two different values. So, in order to get out of it, we are nowadays using digital micrometer. A multifunctional digital micrometer is being very popular in the recent times. The readings are very easy to measure. The push of a button can convert a reading from decimal to inches and vice versa. Till today, people use decimal. So, some people use millimeter, some people use inches for measurement. So, 1/4 of an inch, 3/4 of an inch. So, by push button you can quickly swap the values which is not possible for you in the normal manual display. Any position of the spindle can be set to 0 and the instrument can be used for inspecting a job without specifying the tolerance. That means to say, you have a standard, you have made that standard, and then what you do is you reset the button of the digital and make it as 00, and henceforth from that 25 you just try to check the variation alone. The instruments can be connected to a computer, and this can also be used for the statistical information like mean, standard deviation and range today. Mean is the average of data, standard deviation talks about the distribution of the data, range is the minimum and the maximum value which it can. So, you can see here, it can see the decimals, it can go up to 3 decimals. So, here these are something which are used to convert from inches to millimeter and other things. So, here is the least count which is displayed, which talks about 1 micrometer. Inside micrometer, so inside micrometer, the inside micrometer is used for making very small measurements from 5 to 25 millimeter. This is the inside micrometer. So, whatever we had here was outside. So, we can also have inside micrometer, rest all equipment follows the same. So, you will have a main scale reading, you will have a dimble screw. So, these are the vernier scale readings, and then you will try to get the values. So, this is another type of inside micrometer. So, this is a slightly higher end. So, this instrument complies with Abbe's law. The Abbe's law, Abbe's error, we will see that little later. Abbe's law, the axis of an inside micrometer is also its line of measurement. So, Abbe's law is very much. So, Abbe's law is basically to make sure that there is no angle error in the measurement. It is useful for measuring inside diameter of a cylinder. This inside diameter set has several accessories you can add on to it. The main unit is the measuring head, which has a dimble that moves over a barrel, same as the case of a outside micrometer. So, here is the dimble. So, here is a movement which is happening, you can lock it, and here you can see the accuracy, the least count in terms of inches and in millimeter. So, several add-ons can be added such that it can measure the values properly. So, the depth micrometer we have already seen. So, this is the depth micrometer. So, again same with a dimble. So, you have a main scale reading and you have a vernier. So, there is another thing which is called as floating carriaging micrometer. A floating carriaging micrometer is an instrument that is used for accurate measurement of thread plug gauge. So, measuring threads is also a very important parameter. So, this floating carriage micrometer is used to measure the thread plug gauge. The gauge dimensions such as outside diameter, pitch diameter, root diameter are all measured with this equipment. So, till now what we were measuring is only the length, depth, height, but now you see we are also trying to measure the thread. The carriage has a micrometer with a fixed spindle on one side and a moving spindle of micrometer on the other side. So, this is a floating carriage micrometer. So, the carriage has a micrometer with a fixed spindle on one side, and floating on the other. The carriage moves on a fine ground V guide ways or an anti-friction guide ways to facilitate movement in the direction parallel to the axis of the plug gauge mounted between the centers. So, the object is held between centers, okay, and then you try to measure the root diameter, the thread profile using this micrometer. The micrometer has a non-stationary spindle of a least count of 0.002, 1 to 2, that means to say microns. The instrument is very useful for thread plug gauge measurement in gauge calibration laboratories, which is there in NABL accreditations, which is there. So, this is a floating type. So, here you see here is a device. So, and then you can measure it. So, here you place it between the two centers and then we tight it, we lock these two and then we try to measure the deviations. Thank you.